Good morning. I'm Alexis Lau of the Hong Kong University of Science and Technology. Today, I will talk about from outdoor air quality control to indoor exposure management. For a lot of people, air quality is having this idea that, well, outside air quality is not good, but we have a lot of things to do. There's not much we can do about it. In the past few years, we have been working on a project called Personalized Real-Time Air Quality Informatics System for Exposure. We call it PRAISE for short, and since we do it in Hong Kong, we call it PRAISE Hong Kong. The idea here is we want to empower the public with very high quality personalized air quality information so that they can help themselves. In case of bad air pollution episode, they can reduce their own air pollution exposure and hence protect their health. More detail of the information can be seen on our website, praise.ust.hk. We have a very large team. Here is our co-PIs. We have transport expert, air quality expert, big data, mobile app, as well as expert in health and communications. The first phase of our project is to develop a highly accurate and real-time air quality forecast system that can provide accurate air quality forecasts as well as analysis down to street level and provide this information to the public using a mobile app. The way we do it is by first having a large-scale model providing weather information, just like a numerical weather prediction system that most of the people here are very familiar with. So we run a 27-kilometer resolution model all the way covering most of China. And then we zoom it down through a number of steps, down to Hong Kong at 1 kilometer resolution. And then within this 1 kilometer resolution, we use the ADMS urban model to try to include all the urban features. Okay, so one of the big challenge in a city like Hong Kong is traffic emission. So here we work with a transport expert using a model called MATsim, which simulates the traffic in over 30,000 roads in Hong Kong, as well as integrating the transport measurement data from our transport department. So with this, we actually can estimate the traffic flow over Hong Kong at every street. With this information, we actually can have the emission characteristic of all the pollutant, NOx, PM, and so on, over Hong Kong. And we have a very similar system tracking the movement of ships. We have historical data of how ships have been moving, and with that, we can estimate, again, the emission from ships. The final piece is the piece of urban street cannon effect, because we have a lot of high buildings. So there we can use the urban ADMS to include this street cannon effect. So with that, we can have this resolution that is much higher than what is offered by original like ADMS. Like for example, this is a 3 kilometer by 3 kilometer domain. We only have one observation point that is reporting every hour. With the CMAC, we have 16 points, but with the ADMS, we can go down all the way to 2-meter resolution at the roads, as well as about 20-meter resolution in the general area. Okay, these information are basically combining all the historically available data to make the most accurate forecast with a driven by the WRF weather model. Okay, however, there are also variations in the source, like in the vehicle, which we can get information from our transport department, as well as some online resources, like the traffic information on the road. So we use the big data method using data analytics to read the real-time information and then combine it with the forecast, detailed forecast, to get a much higher resolution as well as accurate real-time information. So for example, you can see here our output from different systems. The green one is the CMAP model at 1 kilometer domain. The orange line is the ADMS urban, which kind of can enhance our simulation of the urban effect. But you can see that the ADMS urban sometimes match very well, but sometimes it's not as good. Our Place Hong Kong system, which is the blue line, you can see that with real-time information as further improvement, it can actually match the red dot much better. And our index agreement improved to 0.96 as compared to original one of CMAC at 0.74 or the ADMS Urban at 0.84. Okay, this is for the one of the parameter. We actually check many other parameter, and we can show that for all these parameters all through the year, the Place system can give a better result compared with the old CMAC or just the ADMS. We have now put this system into a mobile app and place the mobile app on the App Store of Android and iPhones. If you want to get it, it's called using the phrase Place Hong Kong. You can see it on the App Store. So this system can give very detailed information about what is the air quality around you, as well as if you are interested more in pollutant concentration or health risk, the app will provide that also, as well as the forecast of air quality for the next 2 days. Okay, so by doing this, we actually complete our mission for our first task, which is having air quality analysis and model for a few days, as well as putting the information in the public's hand. We launched this last year, in the middle of last year. In the past year or so, our main effort is actually in the second part, which is to try to give exposure information, not just air quality, but exposure information by integrating the air quality information we got, as well as the tracking of the user as they move from one microenvironment to another. Okay, but to understand the air quality in different microenvironments, we have to really use new technology, because the existing old type of sensor is too bulky, they are not really useful. So we have developed some sensor which can measure that. And Professor Ling Ji will be talking about those later. So what we have done is using those sensors to measure simultaneously the outdoor air quality concentration as well as the indoor air quality situation in many different places: school, home, offices, shopping mall, as well as a lot of transport mode. So what we try to get is an understanding of the variation of air quality outside and air quality in microenvironments. So with this understanding, we can actually estimate how much pollution people are exposed to as they move around in their daily life. Okay, for example, the app has a route tracking and route selection feature. So if you want to go from one place to another, you can select a type of route, like you want to go by MTR or you want to go by bus. Then there is different route select zone, and what you see is that you can sort it by exposure or sort it by time. For example, if you click one of this, the app will show you the map, which is what is the route, as well as a breakdown of what is the exposure as you walk to the train station, when you're taking the bus, and so on. So you now have a little bit more information about, okay, what type of exposure you would have if you change different choices. Okay. In addition to actually looking at route, because we can actually track the person with their permission, their path as they move around. So we can actually estimate, okay, how much exposure they are having in different microenvironments. For example, in this case, we track on this particular day, the majority really is on a home. And then the next one is really in the office, and the others are much less. If you want to break it down to look at the time, you can actually look at a timeline type of thing, and you can see that, okay, during the early morning, you are staying at home, so you have this red exposure, and then you have to go to the office, and you have to go out a little bit, take the traffic, and so on. So by looking at this, you understand your exposure to pollution much better. And in addition, here, if you click on some of this icon, you can know what is the setting of the pollutant, the parameter. what is the setting of the microenvironment parameter. Like, for example, this user turn on the air conditioning as well as open the window. Okay, this is not a very good thing to do because it wastes energy and also let a lot of outside air in. So if you edit the micro parameter, you can see that the exposure can reduce. So there is an interactive component here which allows you to edit what you have done and see if you change something, what our system estimate the exposure would be. This is certainly not changing your exposure in the past, but by understanding this type of interaction, we hope the user learns that there are simple things they can do, particularly during pollution episode, to reduce their exposure. We can also estimate this is another day, probably another user. They take certain period in a car, and even if you're driving your own car, there are options you can do to change the exposure you get. Okay, so here is an example of actually we have about 22 researchers. We give them an app as well as some measurement device so that they can move around, and we estimate the exposure. Okay, the red is the home exposure. The blue one is the office one, and you can see for most of these people, it's really the home exposure is dominant. I think most people know that the home, because of the time you spend, is really the most important thing. The last user here is actually an outdoor worker. So he spent quite a bit of time at home. Probably he's quite comfortable with outdoor air, so he probably opened the window all the time. So his exposure outdoor as well as exposure at home are much higher than the rest of the researcher. But you can see, even for an outdoor worker, the exposure at home is the largest part. So this actually suggests that we can do quite a bit of things at our home to improve the exposure. For example, this is a hypothetical case. This is for PM 2.5. The estimate is the exposure total unit is about 300, and then the home actually contribute nearly 200. If we can use some simple thing like closing the window or even using an air filter, we can reduce the exposure by maybe 2/3 with these type of small changes. And the overall exposure actually reduced by 40%. We are not considering even any change when the person moves outside. Okay, so this is quite important concept. When we think about air quality control and management, we know that the Clean Air Act of 1970 is very important to change our thinking from controlling individual source in terms of emission to the air quality management of trying to reduce the outdoor air pollutants to protect public health. We want to say, actually, beyond controlling the outdoor air pollution, since people are spending so much time indoor, it's very important for us to also understand there's a lot we can do in exposure management by looking in what we can do ourselves, as well as what buildings can be configured in such a way that they can help improve the air quality for the public. Thanks a lot. This is my talk.